Hello, so today I'm going to be solving a puzzle called Evens and Arrows by Lisztes, which hopefully I pronounced it correctly this time. He did correct me from last time, so I hate to get it wrong a second time, but anyway, this puzzle is pretty interesting from what I see, and the rules aren't too complex, so let's go over them. First of all, we have these arrows. So we have the circle and we have the arrow. So the cells along the arrow add up to the number in the circle. So this is standard arrows if you've done that before. And digits can repeat along an arrow. Now obviously other Sudoku rules may prevent them from repeating. Like these two can't repeat because they're in the same column. These two can't repeat because they're in the same column and the same box, etc. But for example, these two could easily both be a 1, and then this would be a 2, because 1 plus 1 is 2. All right, and the only other rule is we have these gray squares in the grid, and those are even numbers. And so don't forget that that also includes the ones where there's a gray square behind a circle or on an arrow. Those are even numbers. So those are the rules, and if you'd like to try it yourself, go ahead and check the link below. And either way, I'm going to get started. So what I like to do whenever there's an even-odd constraint, and in some puzzles it's more relevant than others, I like to actually highlight the cells that I know to be even or odd in a specific color. So I'm going to use blue for even, so these we know are even, and I'm going to use orange for odd. And I'm already seeing some fairly interesting stuff going on here. So we always have in a row, a column, or a box the numbers 1 through 9. And we know that the numbers 1 through 9 have 4 evens and 2 odds. 2 odds, great. 4 evens and 5 odds. So any row, column, or box right now where we already have 4 evens, we can immediately mark everything else in that group as odd. So again, I'm using orange for odd. And I hope that's okay for colorblind people. I'm actually pretty used to using red and green, which I know is terrible for the colorblind. But usually I'm not recording myself, so for me it's fine. But I will try to get used to using colors like this just to help out those who can't see the difference between those colors very easily. So I think this should do it. So just, I was talking while I did it, but there's 4 evens in all of these rows, and there's 4 evens in this box, and there's 4 evens in this column, this column. Oop, I missed this column. So we may actually know every single even odd. Well, we're pretty close if we don't know every single one. So for example, these have to be even for multiple reasons. This is pretty close. Just making sure I'm not missing anything here. There may be something with the arrows. So here we have an odd plus something is another odd. And the only way to preserve the oddness of this odd number is to add an even number to it. Similarly here, we have an odd plus something is even. If we want to flip the oddness, then we need to add another odd to that. So the rest of these in this box are even. We have 3 evens and 4 odds. So one of these is even, one of these is odd, but I don't immediately see how that works. We have an even plus something is even. Again, we preserve our parity by using an even number, and we flip the parity by using an odd number. That's the way I think about it. So this one has to be even. We haven't even filled a digit yet, but I wonder if we can color this whole thing. Well, this is even, because it's the only one. We need 4 evens in the box. So we have the rest of this column is even. It seems to be working so far. Let's see. Okay, so we've got, yeah, these two have to be even. And one of these is even, one is odd. one of these is odd and one of these is odd. I'm sorry if you're seeing something I'm not. I think at this point I should look at something else because I'm not immediately seeing how the rest of these get resolved. Okay, and there may be a way to do it, but I'm sure we'll get it. So let's see. What is the best way to do this? Well, we know that a 2 can't be on a circle. We've got quite a few. Okay, so here, for example here, I think I'm saying that because I'm pretty sure I've looked at every arrow, and every single arrow, except this one. Other than this one, every arrow is adding 2 cells. So let's just double check that. I'll start at the bottom and work my way up. This one sums 2, that sums 2, that sums 2, that sums 3, this sums 2, 2, 2, 2, 2. All right, are you tired of hearing 2 yet? All right, so all of them sum 2 cells other than this one, which sums 3 cells. And yes, that 2 odds make an even plus another even is even. So what I'm looking at here is, for example, here, we can't have, other than this one. I'm trying to put my thoughts together here. Okay, let's put it this way. When there's a circle for an arrow where digits can't repeat, the lowest we can put on that is 1, 2, which adds to 3, which means we can't put a 2. So for example, this one can't be 2 because we can't do 1 plus 1. So this can't be 2. This one can't be 2 because this can't be 1 plus 1. And this one can't be 2 because that can't be 1 plus 1. So this has to be 2 because it's the only place for a 2 to go in that row, because we know 2 is even, obviously. So 2 plus some odd number is some other odd number. So we can at least say that this is 1, 3, 5, or 7, and this is, 3, 5, 7, or 9. I know it's not too much, but we might as well mark it. So are there anything, I'm sure there's more like that. Now we have to be careful. This one can be 2. This one can't be. So I guess we might as well mark this as 4, 6, or 8. So let's mark all of the, this one is 4, 6, or 8. Sorry, but there's a 2 in this column, so we know the whole column, the rest of them evens are 4, 6, or 8. Same with the box. This is 4, 6, or 8, but can it be 4? No, there's no way, because 1, 2, 3 adds to 6. So this is either 1, 2, 3, in which case this would be like that. Probably shouldn't have typed the full 1, 2, 3. And then for 8 in 3, using 2 odds, can we use a 1? So these 2 would add to 7. So we could be 2, 5. So we could be 1, 2, 5. So we can have 5s in there. We could be 3. Sorry, can we do 1, 4? 1, 4 is 5. And we're trying to add to 8, so we need another 3, so that works. I don't think we can use a 6, because then we'd have to have 2 in these 2. So I think this is 1, 3, 5, and this is 2, 4, because we can't have a 7, because these can't add to 1. And we can't have a 6 here, because we can't put a 1 in both of these. So that's relatively restricted compared to some of these others. We have a 4, 6, or 8 here. So this adds at least 2, and can't, well, I guess we can't put an 8 here, because this is going to be 4 or 6, because if 8 were here, what would we put? These, we know these are even. So we can certainly do 4 plus 2 is 6. We can do 4 plus 4, since these are diagonal, they can both be 4. We can make 8. We can do 6, 2, 8, but I think that's it. Because a 6 here would add with 4 and we'd get 10. So obviously can't do that. All right. This doesn't seem, well, we can't put a 9 here. We can't put a 9 here. So a 9 is going to be up here somewhere. And the question is, can this be a 9? I don't see why not. Seems pretty easy. 4, 5, for example, among others. 2, 6, or to 7 is what I meant to say. Let me just make sure I've cleaned up everything that needs cleaning. Okay, so 2 odds to make an even. These can't be 9. Can there be 7? We can do 7, 1, 8. So yeah, we're just not 9. This can't be 2. But we could be 2 plus 2 is 4. I don't see why not. So yeah, that's just not 2. What am I missing here? I feel like there's probably an obvious arrow. I mean, I looked at the 3 long one. That's the most obviously different one. We can't ever put a 9 on an arrow. So, sorry about that. I had a phone call I had to pick up. So, I promise I was not thinking about this Sudoku while on the phone. And that is evidenced by I still don't know what to do. So, what was I even thinking about? 9s on arrows, I think, is what I was thinking about. So, for example, none of these can be 9. We already know 9's limited here. Okay, so here. This has to be a 9, because it's the only orange in the box that isn't on an arrow. These are 1, 3, 5, 7. These two are kind of linked in that they're going to sum to whatever 1, 3, 5, 7 sum to. That's going to be 4 plus 5 is 9, 16. So these two sum to 6. Is that true? Yeah, I think that actually limits that. Does that mean these two have to be 8? Just to go over that again. So these two arrows have to be odd numbers. And there's only 4 odd numbers left in this box, 1, 3, 5, and 7. And we know that these sum to this value and these sum to this value. So the sum of these we know. We know these 4 cells sum to 1 plus 3 plus 5 plus 7, which is 8 plus 8, which is 16. So that means these two also sum to 16, which means they have to be 8 and 8. That's really cool. I really like that logic. There may have been a different way to see that, but what that means is that we either have 1, 7 or 3, 5 on these, but there's not a good way to mark that. But now that we have these 8s marked, that should be easy to remember. That gives a 4, 6 pair in here, so this is an 8, which is unsurprising given that it's the 3 sum. So let's see. Let me just go over this again. If this is a 2, these sum to 6, so that's going to be 1, 5. We can't use the 3s. If this is a 4, then these sum to 4, and that's the 1, 3. So we always have a 1. And then the 3 or the 5 determines whether this is 2 or 4. This is 2, 4, 6. So this is the only place for an 8. Yeah, we just look at how 8s look in here. And then we can't put an 8 on the arrow, so this is an 8. So to sum to 8, where you're going to have a 2, 4, or 6 there. We can repeat the 4, the moment at least. Okay, so looking at more, I'm looking at this here. Unfortunately, this can be 9. Okay, so does this 2 mean anything? Not really. Not that I can tell. This can't be 1. It could easily be 2. Sorry, 3, I mean, not 2. I was thinking about a 2 here, and I said 2. So these are 2, 4, 6. So that's a 2, 4, 6 in this column. So this has to be the 8. So this has to be 8. That's 4 and 4, 6 and 2. So we have to have an 8 up here somewhere. Can this be even? Don't see why not. It would be a 2, 4, or 6. How are we doing on 8? So we have the 8's here. I mean, pretty much any of those can be, well, these can't be 8, but okay, so 8's one of these two. Should have seen that. And then over here, it's any of these can be 8. In fact, they can be any even number as far as I can tell. All right, what's the next thing to look at? This is 2, 4, 6. So is this. So is this. These two are 2, 4, or 6. I'm marking those for lack of anything better to do. At least that I can see. This can still, so if this were 4, 4, does that cause any problems? It puts a 4 here. I don't think that's the way to go. Okay, so this is an 8. So these can be, if it's a 4, it's a 1, 3. If it's a 6, it's a 1, 5. So there has to be a 1. Is that true? Yeah, because I can't do 3, 3 to make 6. So that means this isn't, oops. That means this isn't 1, which means this isn't 3, because we're adding 2. How about this? This is the same, right? These are 1, 3, or 5 with a 1 and one of these two. So 9 is in one of these two. And 7 is in one of these two. No, wait. 7 can be here. This is 3, 5, 7, or 9. What else is... Sorry about not seeing. I'm sure you're seeing something that I'm not. 6 is in, okay, so for this row, 6 is in one of these two. So this is not a 6. Oops, definitely not a 9 either. Doesn't really do anything for me. Still haven't figured out the parity of these. I think this has to be 9. So if in this row, these can't be 9 for multiple reasons. They're on an arrow and there's a 9 in the box. This we're saying can be 9. This is on an arrow, and there's no way 9 plus something is 2, 4, or 6. And this is on an arrow. So this is the only place for a 9, and that does limit this sum here. So we can still add to 3, 5, 4, 7. Which means that this is 1, 3, or 5. Adding 2, 4, or 6. This is also a 2, 4, or 6. So 6 is in one of these two for the column. So this is not 6. Oh, come on, what else does this mean? There's a 9 down here somewhere. It's not on the arrow. We can look at these. So we have these 4 6s all over the place, which makes these 1, 3, 5s with a guaranteed 1. So this can no longer be 2 because we'd have to put a 1 here, and we know 1 in this box is in one of these two. In fact, oh no, I was going to say it was limited, but it's not. If I could, oh no, actually it is limited, just not in the way I was thinking. So one of these two has to be a 1, because this can't be a 1 from the ones looking up this way, and then none of these can be 1. So the 1s are limited in boxes 2 and 3, are limited to rows 2 and 3, which means the 1 in box 1 can't be in rows 2 or 3, because they already have their 1s represented. It's kind of like an X-wing. And so the 1 has to go here. And because we know that adds to 8, this is 7. And so then this is the 3, 5. Keep hitting the wrong numbers here. Okay, so that's 3, 5. This isn't a 1, so 1's limited down here. Let me corner mark that. And so that leaves 7 or 9 for this arrow. So to add to 7 or 9 from 2, 4, or 6, we'd need 5 plus 2, 3 plus 4, or 1 plus 6 to make 7. To make 9, we'd have 7. Yeah, it's just we're not 9. Oh, but we can't be 1 or 7. So 3 plus 4 is 7, or 5 plus 2 is 7. And then 5 plus 4 is 9, or 3 plus 6 is 9. So we can't eliminate any. That's unfortunate. But we know that these are 1, 3, or 5. Or sorry, not 1, 3, or 5. 3, 5, or 9. Don't see how that gets more limited. And these are 1, 7, or 9. Again, we've limited 1s in these two boxes, so the 1 has to be down here somewhere. Okay, so these have to be 3, 5, or 7. Just looking to see if there's... Not that I see. So there's no way this is 7. So we're either 1 plus 3 is 4, or 1 plus 5 is 6. Do we have to be 1? Can we be 3? 3 plus 3 is 6. So we can be 1 or 3. think I went over this arrow already. We're so close. We have so many of these on the verge sums. What am I missing? Okay, we've got a 1 in one of these two because of the ones looking in from this pair here and this one here. So one of these is a 1, and it's not a 9, so I might as well mark that as 1, or it's 1, 3, 5, or 7. As is this one. I feel like I've marked too much at this point. So, this is a 2. I just noticed this 4, 6 pair here. So that's gonna do a lot. So it has to be a 6. This 4 forces these to add to 4, so they can't be 5s. So that's a 1, 3 pair. I filled a lot. I'm gonna try to make sure I actually, yeah, so this is 4, this is 6, this is 2. This is a 2, 6 pair. Excuse me. This is a 6, 4. This 6 means this is 1, 5. This is a 4, so this is 1, 3. Wow, I'm filling so many things. I feel like I'm going to have to just rescan everything when I'm done. 3 was placed. This 1, 5 means this is a 7. Sorry about my phone there. All right, so what was I doing? I placed a 7, so this is a 5, 3. So this is no longer a 3 or a 5, so this adds to 7. So 3 plus 4 is 7. That's a 2. This is a 6. The 3 was placed. That's 5, 3. This is a 6. This is the 4, because these can't be 4 because it's in the box. So we have 2 and 8 left down here, which means this one's not 8, so this is the 8, and this is 2. So we need a 9 and a 6. Nice. Oh, and we see the 6, so that's 9, that's 6. So we can color these. All right. And we have a 4 down here somewhere. Okay, so we have the odds all filled. So this is even, and we know it's actually a 2. That places a 2 here because these 2's look in. That's a 4, 6 pair. And all right, we need a 4. Don't know where that goes. Okay, so I'm sure there's just other stuff I haven't scanned yet. This isn't a 3. This isn't a 7. Maybe the evens is what I should pay attention to. Or not. I have most of them. Oh, 6, okay. So this is a 4, 6. In order to add to 4, this can't be a 5. So that's a 1, 3. So this is the 5. 2 plus 5 is 7. Last I checked. And oh, we're so close on all the evens. Okay, I think that's what we're getting from the evens right now. So 7's not here, and this is a 1-3 pair, so that's a 7. This is not 7. Okay, so 1, 3, 5 triple in here means this is not 3 or 5, so this is 9, this is 7. 7 is going to be 2 and 5, 8 and 2. My dog Rocky is very happy that this Sudoku is almost solved. We got the 2 5s here. He's actually happy that my girlfriend just got home. All right, so that's a 9. I feel like we're done. We just gotta finish this off. 1 5 pair places 3 and 1. This 1 5 must be resolvable. Yeah, it is. So this is 1 5. What's left here? So we've got 5 or 9. So this is the 9. This is the 5. This is a 3, 1, 3 and 1. Sorry about that. This is a 5, 7. So we have 1, 3 and 5, 7. So this is a 9. Could see that from the column. At this point, this is where the colors actually kind of get in the way a bit, but I'll keep it colored. This triple is going to be 1, 3, and 4. Looks like. So this isn't the 4 because it has to be odd. Ah, this column's done. So this is not 1. So that's the 1. And this is 5, 3, 7. Leaves a 1, 9 pair there. This is no longer 1. So for the column, we've got 7 and 9 left. Oh, we placed this 8, so this is an 8, which makes it even. And there's 1 left for this column, which is 5 again. 7, 5. Let me color this before I forget. Yeah, we're basically done. So this was a fun puzzle. Not too hard today, which I think is absolutely fine. I've had enough hard puzzles recently, but it was interesting. There was some really nice logic in here. I think my favorite was in box 1. Let me just finish this real quick. All right, so we'll highlight this blue and this orange, and there we go. So that's how you solve it. I liked the logic of. I wonder if I could have seen that earlier, but when I did see it, it actually kind of blew my mind a little bit that worked out that way. It forced the 8s into these two. But yeah, well-constructed puzzle, and I enjoyed myself solving it. And I finally have a video that's not an hour long with fast forwards, so that's awesome. So I hope you enjoyed solving it as well. And if you enjoyed this video and would like to see more like it, the best thing to do is to subscribe so that you can see in your feed when I post new ones. And I'll put boxes on the screen for some other videos you might enjoy. And otherwise, until next time, thanks for watching.